overleaf fitting.
Okay.
Not in overleaf. I mean the Dropbox folder. So it's only Nando
Okay.
who has no access to the Dropbox folder.
Okay. Okay.
So I should start sharing.
Yes. That's true. Okay, fine.
So I think it will be good to maybe share the whole screen, so that when I run some figures and then they come out.
Yes.
So is my screen visible?
It is.
Yeah. So I just made this code to that can try to simulate what when we vary parameters. So all of those looping parameters.
Okay.
Yeah, and so I have it there. The main. So these are just the files I always when I add some things to the path. Like here, when I want to read the data, yeah, this is reading the data, and then this is another folder, line 8, that I use to automatically save figures. So when I want to save my figures, I don't have to manually save them. So when I run the program, then it just saves automatically with the specifications you want. Yeah, so something. So if you want to Google something which is called export fig, but there are people who use other alternatives. I think like I think this one is save as, another one is print f. There are several. So the advantage of this automatic saving is you can save your figure with the format you want, the dimensions, also this what we call the DPI, maybe the quality or the compression level.
Yes.
Yeah. So some of these when you run in your laptop, possibly they will not work. You just comment on them.
Okay.
Or you put your proper, if you have this, because this is the only thing you need here, just downloading this file is just a file, so it is stored in my Dropbox.
Okay.
And since I have several files in different places, so I didn't want to keep on having the same file in multiple places. So I just have it at one place, and then I whenever I want to run any program, I just add this path to a program I'm running.
Okay.
Yeah, and I think also even this one will not run here. It will not work because this is the path for my office computer. Let me look for the correct path instead of.
Okay.
Yeah. So I can just copy this, and then so the only thing I just need, this is the rest are the same. So therefore, yeah, my.
Okay.
Yeah. So this code I made it, and then I'll do some. I think I put one simulation in the overleaf, only now varying beta, and also they are here, they are saved. And so maybe I can just go through the same first. Yes. So I had started now varying. This is theta, but let me still keep varying beta.
Okay.
So I'm using x1 because let me load this file. Nando has these files, right? Are we still available?
Yes.
You know, I'm not seeing my screen. So when I ask Nando and then I see he's not responding.
You're not seeing your screen.
No, because now the Zoom is behind the Matlab, so I cannot see the Zoom.
Okay.
So this is just the same files Nando has and they are still here. So the parameters are in whichever all the parameters are stored in these files. Yeah, so my params is just because I put names on the parameters, so that when you give somebody this, then they can be able to access the names.
Okay.
So you see, beta is in log scale.
Yes.
Yeah, so that's why. So whenever I call beta, then I have to find the exponential of beta.
Okay.
And then I have recovery days, which means if you want gamma is 1 over recovery days, you have delta is also in the log scale, you have k, you have theta, and then you have kappa, epsilon, and then you have the detection rate. This is only used for fitting. And then you have also q, which is also used here.
Oh, fitting as well.
No, Q is in the model.
Okay.
Yeah. Only the detection rate is just used in fitting when you want to compare now with the observed data, because so you scale the infections. So they are just in the same file as X1. So I just put them here. So when you in X1 only contains this second row.
Okay.
I just put them here so that somebody can see the name, so that you can know whatever is contained in X1.
Okay.
So when I want to vary beta, first I like sometimes making, so I just have this program and then I call, these are the various simulations. So I call it here. So whenever I run this, then it will run the other file.
Okay.
I just do this so that I don't have one program that is contains a lot of things.
Yes.
So yeah. So if you want, you can make it in form of a function or just a file, and then you put the file here. If it's a function, you call that function whichever in the main file you are working on. So if it's beta, then I want to vary beta. I just create a vector here. I vary beta from 0 to 1, right?
Yes.
Yeah, these other things are just almost the same. I'm just creating this. I want to separate them as structure, but they're same as what Nanda was doing. And the constant parameters, phi, mu, pi, n naught is the total population, and then we have the vaccination time. That's the TVAC. So when I vary beta, maybe let me first, to understand, let me first comment on all the others from wave 2.
Okay.
Going to the fourth wave, and also combining, because I'm also now combining this, so I can suppress this.
Okay.
But so there will be many figures produced, because all these figures.
Okay.
So each figure, you see, like this is for the wave 1, figure 1, 2, 3. Wave 2 is figure 4, 5, 6, 7. So I renamed them here because if I want to save, I'm saving from here. Then I can save whichever figure I want.
Yes.
Yeah. So if I say export fig, for example, if I can suppress this, then this will save all the figure 1, F1, F2, and F3.
3. Okay.
Yeah. So when I vary this simulation, so since this is within the loop, so I'm having a loop here where I'm varying the beta, and so at each of this loop, each of this I, then I take the beta I replace it with whatever the other value is, which is the other end. And so here, here I put it as, that is beta end. Oh. Yeah, okay. And so let me put this, because so I want I removed the log because I know the beta has to be in the log scale. So I have to convert the other values to log scale, right? But if you don't want to work with the log scale, and then you just remove the log scale, and then you use the beta here in the PP. So all these things are the same. You can use whichever you want. It's just provided you call the parameters.
Okay.
If you use the PP, then you have all these parameters in the normal form, not in the log scale.
Okay.
But if you use X1, then you have these parameters in different formats.
Yes.
Yeah. So if I use PP here, then I'm having what? I can just call beta directly, right? But if I'm using X1, then I should convert this beta into the log scale. So whatever beta I have, I convert them to log scale. So since in the simulations, I will find exponential.
Okay.
That's how this is made up. We have this model output. You see model output, where is beta? You see beta?
Yes. It's here.
Exponential. So it means if I want to use this one, then I have to supply the log value. But if you want to use the PP, then you remove this exponential here, and then you call the correct PP. You don't have to. So that's what I say. So some of this is just tweaking depending on what you are working on.
Okay.
And then seeing how the program is. So it means if you want to use PP, then you can remove these exponential values. And then you can just create another program here, which is not necessarily the same as this. Because the main part of this program is only this part. Only this. That's the main part. And then you supply parameters, which you can supply from either the X1 or you can supply from the PP. Yeah. So that will depend on the on somebody's preference.
Okay.
So
in your in your experience though,
yeah,
what's the advantages of the two? Of course,
I used log scale only in the fitting, and so you know when you want to sample parameters, for example 0 to 1, right? And then you have a very small range of sampling that value, the parameters. But if you want to, you can convert that one into the log scale, and then you know that 0 to 1 in the log scale is 0 minus infinity to 0, right?
Oh yes.
Yeah, so you have a very wide numbers to choose from. So you have a longer scale to choose from.
Okay.
Yeah, so that was just a technique of fitting. So since I fitted some of these as log values, so that's why I kept the log part in my simulation.
Okay.
And so so you find that I mostly did this to the parameters which had very narrow range, like the beta, the delta,
yes,
epsilon. I think epsilon, I don't know if I think I also did to epsilon, and then the ascertainment rate, that detection rate, because most of them are 0 to 1, 0 to 1. So I wanted a very wide scale to choose from. So it means you choose from the log scale, and then so when you want to compute, you now find the exponential. So you transform back to the original interval.
Yeah, no, it makes sense.
Yeah.
Okay.
And so and that's why even in my fitting, I did not call gamma directly. I was sampling from the recovery days. And then once I have the recovery days, I now find gamma by finding 1 over the recovery days. So the reason is because when you find gamma, you find is 1 over, so it's a small number, it's also a fraction.
Yes.
But so recovery days, maybe you find that if you choose 3 to 30, then you have a wider range, 3 to 30. So I sampled from the recovery days, but so I noticed that gamma is 1 over the recovery, right? And so I find the reciprocal of that one. So it's much easier. So that was just a technique of considering a wider scale of choosing from.
Yeah, I think it makes sense. It makes sense. Yeah.
And so here it was 5 because I finished the gamma, the beta value, the beta. And if you check in the manuscript, I put the figures for beta.
Okay.
So I was starting the vaccine. I think 5 is vaccination. But so since let me just start with this, I illustrate. So this is gamma 1, and then so this is what I put here, the log, because I say that I call in the log because I'm using x1.
Yes.
Yeah. And so here where you see that beta end is the same as x11. So what I wanted here is no, I also plot the curve corresponding to the fitted beta. Instead of just varying beta from, so you see like here, no, it's many fit. So here I'm varying beta from 0 to 1, right? 0 to 1.
Yes.
But I wanted within this variation, I also have the curve for now the fitted beta.
Okay.
So we can see how they vary from that fitted beta.
Okay.
Okay.
Because
and so
beta.
Yeah. So let me try to now run this and then see if we don't have errors or if we have errors. So you see here, this is just complaining about some of the parts. Like this first, because this first part is for my office computer. Yeah, so that's what is giving you a warning. Yeah, finally. So are recognized functional variable AD or D for so
89.
no, I know because so some of these things were because I was running these simulations in my office computer. So it means OD49 is only available in MATLAB 22B or 21 or 21B and beyond. I think 21B.
Yeah. 21.
Because in the office computer, I think on office computer, I have the latest version. I think it's supposed to be 22M or 21B, but I have the latest version in the office computer.
Okay.
But this is also still 21A and doesn't have OD 89.
Oh.
But so I can, it's just only changing this OD 89 here, and then we can just go back to our 45 or 23. Yes.
23, I think 23 was taking less time. I don't know.
Yeah, but I think I think this still will.
Oh, okay.
Yeah, because but why is it still better? I just only solving one thing.
Yeah, because I remember last time on Nandwa's computer, I think it was taking
So much time.
the old 45.
But I think also today my laptop also it has been updating, so it is also I think it's also I suspect also the laptop is slow because it has finished.
Yeah.
So this when you see this display, I display the word save. So that one comes at the end or now after plotting all of the simulation and then it starts saving the figures.
Ah, okay.
But so you see some of these figures. Did I leave the names for saving? Maybe it's taking time because I left the names. So you see there are so many figures, 15, but some of them are blank because I just created them in different waves. So I think so the first wave is the first 3 figures.
Yes.
So you see this is but why do I have the same thing again?
Yeah, it's the same thing. Yeah.
No, because what happens? Maybe I'll check what I'm plotting and let me hope it didn't save this. But so I am plotting in each. I'm plotting 3 different things: the recovered, the infectious, and vaccination. Yeah. So what is plotted there is only the vaccination. I just have to change here whatever I'm plotting. So in the figure 1, it's 4, but this is strange. So because x log beta, and then so in the first figure F1, I'm plotting 4, which is vaccination. And then in the second figure, I'm plotting 3.
Yeah.
And in the third figure, I'm plotting 5. And then so I don't know why this thing is plotting everything as vaccination. So in that case, I don't understand what is happening.
Okay.
Yeah.
And on that one, I think on line like 28, I think up until for the waves, it doesn't matter. Like
Which one?
See them. These waves, I think.
This?
Yes. Like
No, this doesn't. This is just bringing out an empty figure where you can plot on.
Yes, that's true.
Yeah. So if I don't want them, I can just still comment on these 4 files. But this will be strange. Let me see.
Yeah, that's just brought those 3 yes, which are the same.
Let me see something here. So beta end is the same as x1. No, it's not supposed to be x1. It's supposed to be pp dot beta. But this one does not. This one should not cause anything.
Okay.
Vaccination is okay because that's in the first wave. Vaccination is 0. In the second wave, infected. In the third, recovered.
And
I think let me see. I hope I understand. I think I understand something. This should be 28. And I think that's what maybe how I am getting error.
okay.
No, I told you when you read, I think I told Nando something about this, right?